All right, so for the activity series lab, what we're going to be doing is looking at metals and solutions that contain the ions of those metals. So what you see on the board is the collection of metals running down the most left side, and then the solutions that we're going to be using in the middle, and then on the far right side in brackets is the ion of that metal. So really, as you know, the reaction is between one metal and another metal in solution form. So what we need to do is have a solution that contains those metals. So the actual layout we're going to be using is going to be on this paper here. So what I've done is I've taken 6 different metals. I've got iron, zinc, nickel, aluminum, magnesium, and copper. I've cleaned them all to make sure that it is metal exposed and not some kind of layer of metal oxide on top, although we'll come back to that in a moment. And then what we're going to do is we're going to place a couple of drops of each solution on the metal strip in the same order. So across the top, you probably can't read it, but it is iron +2, zinc +2, nickel +2, actually says 2+, aluminum 3+, magnesium 2+, and finally copper 2+. Now I mentioned about the oxide layer, and I did clean them. There are a couple where the oxide layer forms very, very quickly, and it's a very durable oxide layer, which makes it means the results that we get might not be exactly in line with the activity series as you know it, simply because certain elements, certain metals appear to be less reactive than they actually are. But I'm going to go ahead and put the drops on, and then we'll come back to it. So what I did was I put the drops on. Now there's no need to put iron solution on the iron metal or zinc solution on the zinc metal, so you'll notice that for some of them there's a bit of a gap there. Some of them I kind of stopped paying attention and got a little carried away putting the solution on. So some of them have solution for everything and many of them don't. Okay, so what I'm going to do is, it's been sitting for a minute, I'm going to clean the solution up so we can get a look at the metal, because if you see spots on the metal, that means there was a reaction. So I cleaned up the metals, just took the solutions off so you could kind of see them. Really what we're looking for is if a reaction happened, a metal was formed. A solution was formed, but also a new solution was formed, but also a metal was formed. Metals don't dissolve very well. So any place where we see a dark spot on the strip of metal is going to tell us that a new metal was formed and it was starting to precipitate out. I'm going to zoom in on our metals so you can kind of get a better idea. Sorry, that was a little choppy. Better look at each one. The top one is iron again. Followed by zinc. I'm just trying to, there we are. Followed by zinc. A couple of definite spots and then maybe a questionable. Nickel. Nothing really obvious on nickel except maybe down on this end. I'm not sure how well it shows up in the glare, but there's a couple spots where you can tell some liquid had been, but nothing that's really a spot as such other than that end. I'll try a couple of different angles before we're done. And then we have aluminum and magnesium, followed by copper. And again, no real spots in copper. There's a couple of points where you can tell liquid had been. Let me just try and get a different angle on this. And I'll zoom back out. Okay, from this angle you can see the a couple of spots a little bit better. This particularly the one on nickel and the one on aluminum. Things might have got shifted around a little bit. Oh, there we go. Got fixed. But anyway, from there, what we're going to do is we're going to look at which one has the most spots on it. That metal is the most reactive. Which metal has the least number of spots on it? That metal would be the least reactive. And then we'll carry this on another time.